Hello guys, my name is Balkrishna Srivastava and welcome to Code with Biggie. So in this video, we write a Java program to find the factorial of an integer recursively. So before we begin, it is a request, please subscribe to my channel because your subscription is very important. Out of 100 views, only 1 or 2 will subscribe. So please do subscribe to my channel. Alright. So given a value n greater than or equal to 0, I have to find the factorial of it recursively. So what is a factorial? N factorial. So this not symbol is a factorial symbol. N factorial is defined as n into n minus 1 into n minus 2 till 3 to 1. That is, n factorial is the product of all integers from 1 to n. Alright. Therefore, we'll have 1 factorial as 1. 2 factorial as 1 into 2, 3 factorial as 1 into 2 into 3, 4 factorial as 1 into 2 into 3 into 4, and similarly 5 factorial is equal to 1 into 2 into 3 into 4 into 5. Okay, alright. And factorials are defined for n greater than or equal to 0. Okay, so when you put 0 into this, the result will be 0. Okay, but by definition we have 0 factorial equal to 1. Alright, 0 factorial is not 0, 0 factorial is 1, and this follows for all values greater than or equal to 1. Okay, so I've already written a solution where I find the factorial of n iteratively. Okay, I will add the link of that video in the description. Okay, to solve a problem using recursion, we need two major points. First is, problem can be solved in terms of subproblems. That is, in order to solve a problem, if we are able to divide that into subproblems and divide the subproblem further into subproblems, then we can use recursion. Okay, that is the first point. Second point is base case where the recursion stops. That is when we divide a problem into subproblem, that subproblem is divided into further subproblems, and this process continues, but this process of dividing a problem into subproblem has to stop somewhere. Otherwise, this process will continue infinitely and we'll get a Stack Overflow error. Okay, alright. These two conditions should be met in order for a problem to be solved recursively. Let's see how we fit these 2 points in finding a factorial. Okay, so 1 factorial is 1, which is equal to 1 into 1, and 1 is 0 factorial into 1. Okay, 2 factorial is 1 into 2 equal to 1 into 2. Okay, taking this one separately. Now 1 equal to 1 factorial into 2. So 2 factorial is 1 factorial into 2. Similarly, we have 3 factorial is 1 into 2 into 3. 1 into 2 taken separately into 3. Okay, 1 into 2 is basically 2 factorial. So 3 factorial is 2 factorial into 3. Alright. Similarly, we have 4 factorial as 1 into 2 into 3 into 4. If we group 1 into 2 into 3 into 4, 1 into 2 into 3 is 3 factorial. So 4 factorial is 3 factorial into 4. From this, we can say n factorial is n minus 1 factorial into n. Okay, and this is our first equation. Okay, which is basically point A, solving a problem in terms of subproblems. Find n factorial using n minus 1 factorial. Okay. Second thing, base case. Base case is where recursion stops. So in our case, base case is 0 factorial equal to 1. Okay. Because at this point, okay, we cannot divide this problem further into subproblems. Okay. 0 factorial is 1 is basically your point B, and this is point A. Alright. And using these two, we can solve this problem recursively. Okay, so I'm going to use these 2 points to write a code. So I'm going to say int factorial, okay, takes an integer n and returns the factorial of this integer, and that's why the return type is int. Okay, so our base case is if n equal to 0, we return 1, and obviously n will be greater than or equal to 0 because for n less than 0 we don't have factorials defined. Okay, this is assumed that n is greater than or equal to 0. Okay, for n equal to 0 we return 1. Okay, the return value is 1 because we cannot divide this problem into any further subproblem. So we say if n equal to 0, we return 1. Okay, alright. For n greater than 0, we can use this. Okay, n factorial is n minus 1 factorial into n. So return value can be calculate n minus 1 factorial. So call this recursively passing n minus 1. So calculate factorial of n minus 1 multiplied by n. Okay, and this is your code to find the factorial recursively. Alright, so this thing, okay, is your 0.2 and this is your 0.1. So this line is basically, this recursion is basically 0.1, this base case is 0.2. Okay, alright, and if you are able to formulate any problem in these two terms, you can solve it recursively. Alright, okay, so let me dry run this for n equal to 5. Okay, so 5 factorial should give me 1 into 2 into 6, 24 into 20. So 5 factorial should give me 120. Okay, using this code. Okay, so I'm going to use f short for factorial. Okay, and it takes the value 5. So n in this case is 5. Condition is n equal to 0, which is false. Okay, 5 is equal to 0 is false. The return value is this. Return value from this call with n equal to 5 is going to be factorial of n minus 1, factorial of 5 minus 1 into 5. Okay, factorial of 4 into 5. Okay, so this is the first recursive call to factorial with n equal to 4. So n is 4, n equal to 0 is again false because 4 equal to 0 is false. So return value, we come here again for n equal to 4, return value is factorial of n minus 1, factorial of 4 minus 1 into 4, which is equal to factorial of 3 into 4. Okay, factorial of 3 is another recursive call with n equal to 3 to factorial. Okay, n is 3, n equal to 0 is false again because 3 equal to 0 is false. Okay, we come here, this condition is false, we come here, the return value in this case is going to be factorial of n minus 1, factorial of n minus 1, 3 minus 1 into 3, factorial of 2 into 3. Okay, this is another recursive call to factorial with n equal to 2, n is 2, n equal to 0 is false again, 2 equal to 0 is false. This condition is false for n equal to 2, we come here, again return value in this case is going to be factorial of n minus 1, factorial of 2 minus 1 into 2, factorial of 1 into 2. Okay, another recursive call to factorial with n equal to 1, n is 1, n equal to 0 is false because 1 equal to 0 is false. For n equal to 1, this condition is false, you come here, return value in this case is going to be factorial of n minus 1, which is 1 minus 1 into 1, factorial of 0 into 1. Okay, factorial of 0 is another recursive call to factorial with n equal to 0, n is 0, n equal to 0 in this case is true. N equal to 0 in this case is true, so return value is 1, so return value is 1. Okay, so f0 basically returns 1, so f0 returns 1. Okay, f0 returns 1, so this basically becomes 1 into 1 equal to 1. Okay, so the return value from f1 is 1 into 1, 1, which is 1. Okay, f1 returns 1, f1 returns 1 multiplied by 2 is the return value for f2, which is equal to 2. So this returns 2. Okay, this returns 2, so f2 returns 2 multiplied by 3 is the return value for f3, which is 6. So f3 returns 6. Okay, f3 returns 6, which is multiplied by 4. So this value is the return value for this call. So this returns 24. Okay, now f4 returns 24, which is multiplied by 5 equal to 120 is the return value for call to f with 5, which is 120. Okay, so f5, okay, factorial for n equal to 5 returns 120, which is the answer we are looking for. Okay, so this was the solution to this problem where we find the factorial of an integer recursively. Okay, this code is pretty short. Okay, this is just 3-4 lines of code, but this understanding is very important, right? So that you can relate how to solve recursive questions. Okay, because this is what is going to help you in your future concepts. Okay, so before we move on to running this code on a system, it is a request to please do subscribe to my channel. All right, okay, and let's move on to running this code on a system now.
So this is the code we wrote and discussed. So this method is a recursive method that finds n factorial. This is the base case, 0 factorial is 1, and this is the recursive case, n factorial is n minus 1 factorial into n. In my main, I will print 0 to 10 factorials, okay, less than equal to 10. All right, and I'll print I factorial, that is n factorial, as calling this function factorial I. All right, so let me run this. Java C factorial 2, because this is the factorial 2. Java factorial 2. 0 factorial is 1, 1 factorial is 1, 2 factorial is 2, and so on. All right, okay. What if I make this I to 20? Now, since factorials are large values, after some value of I, integer data type in Java will not be able to hold the factorial for I. Okay, so let me run this. Java C. All right, okay. Till 16 factorial I have this, but after that the values are going negative. Why? Because I'm crossing the range for the maximum value that an integer type can store. How do I find the maximum value that an integer type can store? I can say system.out.println maximum value an integer can hold, okay, is defined as integer, okay, the wrapper class integer for int dot max value. Okay, so if I run this again, Java C, okay, so the maximum value an integer can hold is this. Okay, so when this value is crossed, so this value is less than this, okay, but this value is larger than this. Okay, so you go on to the negative part. Okay, and this value is basically 2 to the power 32 minus 1 minus 1. So if I want to verify that, okay, this is equal to math.pow 2 to the power 32 minus 1 and minus 1. You see these two values will be exactly the same. Oh, so I need to put this in an entire parenthesis. Okay, so you see maximum value integer can hold is this, okay, into 10 to the power 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and this exactly is the same number. Okay, and this is because integer is made up of 32 bits. All right, that's why you have 2 to the power 32 minus 1. Okay, so how do I store the factorial for large values? Because this is the method to find the factorial. But how do I store them? I can use java.math.bigInteger class. Okay, so instead of using integers everywhere, I am going to use big integer. So I am going to say return type is big integer. Okay, and you multiply this via a big integer. Okay, so big integer is a class that can handle large values. So in the constructor for this big integer, I need to pass 1. So I can say this, because I cannot pass integers or long values to big integer constructors. I have to pass a string, okay, which contains an integer. So I'll say this, all right, or I'll say this for convenience. Okay, and in this case I have to pass n here, so I'll say blank plus n, so converting this integer n to string. All right, and I rename this to factorial big int. Okay, so factorial big int is the recursive call for this. All right, and it takes n minus 1 because this is taking an integer. All right, if n equal to 0, you return 1, otherwise you return n minus 1 factorial into n. All right, and I'm going to alongside this print factorial using big int. Okay, so let me run this. Java, oh, import, I forgot the import keyword. Okay, Java C. Oh, I cannot use this. Okay, so I have to use dot multiply. Okay, dot so multiply this big integer by this big integer. Okay, it gives you another big integer. So Java factorial 2. So you can see now my 11 factorial is correct, 12 factorial is correct, 13 factorial is correct, 14 factorial is correct, 15 factorial is correct, and so on. Okay, all right. Okay, in my previous case, I was getting the correct factorials for integers only till here. Okay, only till 12 factorial, right? Only till 12 factorial. Okay, after that 13 factorial changes for integers. Okay, all right. Okay, so if you want me to tell you more about the big integer class, please let me know in the comments. I will add another video to explain how big integer works. All right, so this was the solution to this problem, and I hope this was helpful. So please like this video, please subscribe to my channel, and please share my channel as well. And if there is something that you do not like about this video, please just don't press the dislike button. Please also let me know in the comments what was that you did not like in this video. And you can also mention in the comments if there is a question you want me to solve, or if there is a concept you want me to discuss. Thank you.